Hello guys, in this tutorial, this is my tutorial 1, and in this tutorial I'm going to teach you about the number systems. You know, in day-to-day life we are working with a lot of numbers, right? So you can have 10, 20, 34 and 43 and like that. So many, these are some kind of examples for the numbers. You are dealing with a lot of numbers, right? And in day-to-day life we are working with decimal number system. It's very important. We are dealing with the decimal number system, which we also call base 10 number system. We call this is a base 10. Its base is 10, right? This number is in this decimal number system, the base is 10. And in the decimal number system, we can use 10 digits to represent a number. A decimal number is used 10 digits, like from 0 to 9 symbols. Right? For more detail, you can use 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 to represent a number in decimal number system. And also then now I know a lot of people don't know there are number systems, like they think these are the only number system we have, decimal. No, there are a lot of number system, like it's infinite, there are infinitely many number systems, but actually in computer science we are using binary number system, because I will describe it about it more in later in this video. So and now I am going to um, teach you how a number is actually made. Like if you take this the number 3024, in this number, how this number is made is very important to know. Like in this number, you can see this number has 4 digits, 3024, and um, in this number is made like this. How? I'm going to show you. This every position, this every number has a value, has a position value. Like this 4. If I take this 4, it has um, a position value of 10 to the power 0. Right? This position is 0. This position is 1. This position of 0 is 3. This position of 3 is 4. Right? So 10 to the power, the position number is 0, times 4, the value. It has this position value. We also call it weight factor, right? So we also call it weight factor, okay? So keep it in mind. I will write it here, weight factor. Like that. You can also write the position value of this 2. This 2 is also the position value, like the position is 2, right? And 10 to the power of position is 2, right? This position is 1, right? So sorry, this is 0 and this position is 1, and it's multiplied by the value is multiply of the value here is 2, right? Okay. Then if you consider this 0, it is also have position value. Okay, so if you consider the 0, sorry, right? If you consider about this 0, it also have a position. Like it has, the position is 2, so you get the 10 to the power 2, right? And you have to multiply this one by the value here. Value here is 0. So you may wonder, why do we use 10? We use 10 here because our number system is, the base of the number system is 10. and yeah, and this 0 1 2 other positions. This is 0th position, first position, second, and this is third position, and these are the numbers here, right? Values here. 4 2 is there, 0 is there. In the same manner we can do it for 3. We have the number system is 10, and um, you can get the power of the position is 3, and multiply by the value 3. So after calculating the values, and you can actually add them, you can do the add operation when you get the values, right? Here you will get 10 to the power 0 is 1, and 1, and when it multiply by 4 the value is 4, right? So this value is 4. And in the second one, when 10 to the power 1 is 1, so 10 to the power 1 is 10, and when multiplied by 2 is 20, right? And in the same manner you can do it for here. 10 to the power 2 is 100, and when any number is multiplied by um, 0, the value is 0. You know, it's really so obvious. And 10 to the power 3 is 1000, and when it is multiplied by 3 the value is 3000, right? So when you add these numbers together you get 3020. 3000 plus 20 is 3020, and when we add another 4 here the value comes 3040. So this is how 2024, this is how this value is made, right? And this is the decimal number system, and you should know this is not the only number system we have. We can have any number system, like you can have the base 1, base 2, base 3, base 4, base 5, like up to infinity you can have number systems. But in our practical, in our reality, we are using this decimal number systems. Now we are going to deal with some another number systems we are going to use in future. Like we will take an example. You can have base 2 number system, right? Base 2 number system we also call binary number system. Base 2, right? Base 2 we also call it like binary number system. In binary number system, as I said before, in decimal number system you can have 10 digits from 0 to 9 that you can use. In binary system, as this is base 2, you can have 2 digits. Any guesses what are them? What are the symbols you can use? Yeah, it's 0 and 1. The number of symbols you can use is 2, and how many, what are the symbols actually? 0 and 1 is there. So normally in lot of computer systems, not lot of, all the computer systems, we use this binary number representation, because you know in computers all the things are electronics, and when the voltage is high, we consider it as 1, and the voltage is 0, we consider it as not voltage is low, not 0, it may be low. In that case we use 0. Okay, so this is base 2 number system. At the same manner we can have base 3 number system, right? But there's I don't know a specific name for that, but we can use base 3 and 2. For base 3 number system you can have 3 symbols. You can have 3 symbols, and what are they? You can have 0, 1 and 2. Yeah, so like that you can have base 4 as well. right? Base 4. In base 4, how many digits, how many symbols you have represent? You have 4. You have 4 symbols, right? What are they? 0 to 3. I will write the symbols you can use is 0, 1 and 2 and 3. So these numbers can be used with the in base 4. Okay, like that we can have a lot of number system up to infinity. There is no actually limitation for that, but in the real case the decimal number system is really used, and in the same type we use binary system in our computers. Actually it is really useful in computer science, and yes, this one is very much useful. Okay, and there are two more number systems which are useful. Actually we use them, like base 3 and base 4 number systems are there, but we don't use it quite we don't use it quite frequently. But there are two number systems, that is base 8 and base 16. Base 8, so there are lot. Okay, there are lot. You can have lot of number systems, but I will talk about some important number systems only now. Just think the base 8 we also call octal number system, right? Octal number system. Right, in there you can have you have 8 numbers to represent, and it's obvious what are the symbols. Actually it's 0, 1, 2, 0, 1, 2, 3, 4, 5, 6 and 7. These are the numbers you can use for to represent octal base 8 number system. And the other number system is any guesses? The number system is base 16, hexadecimal number system, right? The next important number system is base 16. We also call a hexadecimal number system. In there, right? In there you can have 16 numbers to represent a number, and you may think like, what are the numbers we can use to represent these hexadecimal numbers? Actually you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Can we write 10? Can we write 10? Again you will see this 10 is 1 and 0, so you can't write 10. Right? There should be 16 symbols to represent a hexadecimal number. But you have to think like, you can't write 10 because 1 and 0 is already there. So you will write A. Instead of 10, you write 10, A. And B and C, D, E and F. Yeah. These are the numbers. These are the digits we use to represent a hexadecimal number. And you may wonder, when you see a number, right? When you see a number, let's think you see some number, you see a number in somewhere like this. How can you know using what kind of number system is this number is represented? Like, what is the number system of this number? You can't say like this is 234 because it can be base 5, base 8 as well. So you can't say what's the value of this actually, because like normally we are dealing with the decimal number system and normally we know this is 234. But just think another planet which is not using now decimal number system, right? So they may be using another number system like octal number system. Yeah, there can be some planets like this. There when you go and see, this is out, this is 234. No, it cannot be like that. Right? So it may be some another number system. So how can you find what kind of number system is this, right? From which number system is this number is represented? To denote that, we write the numbers, the value of the number system in the bottom of the number represented number, like this thing. This is represented by number in the base 5 number system. Then we have to write it like this. Okay. So then it is very much clear. This 200. This is 234, right? Not don't talk. Don't tell like 234. It is in decimal, right? Through 234. 234 in base 5. Actually, this is not the 234, right? It is in decimal. We are talking with decimal number system, and it's obvious. But you know, in every time the numbers don't need to represent in decimal number system, right? So in that sense, we talk 234 in base 5. Like, can you think? What is this number, right? Can you say it? But this is the other thing is very important. I forgot to tell you. Just think, in this number, this is not. This is the base 6. 1, 2, 3. Now that number is represented in base 6. Okay, and you may wonder, like, but in day-to-day life, we write when you have this number, you call it like 10,000, and you don't need to worry about the number system because we use this one, and we have a convention, like if there is a number, just a number without the number system, without the base of the number system, we consider it as decimal, right? Because we use decimal number system. And if you know, if you have somewhere like just a number without the base, we consider it as decimal. That's why we don't care about the base of the number system in day-to-day life. We don't see any base in the numbers. We just have the numbers, right? In those numbers, all of the numbers are represented in decimal format, right? They don't like, it is a convention. Okay, so to represent decimal numbers, you don't want to write the base. You can write, it's not wrong, but it's not needed. This is 2000, right? And if there is something like this, 2000 and base 3, right? So this is just think this base 3. Now you cannot say this is 2000. 2000 is in decimal format, right? This is 2000 in base 3, right? So hope you clear what the number systems are, and what are the number systems, and what are the useful number systems, and how to represent a value in a particular number system. So this is 2, 3, 4 in base 5. Like that, you can represent the numbers in any base in any number system. So, and I think you hope you get a clear idea about what number systems are, and how to represent values, and what are the weight factors, and like that. So in the next tutorials, I am talking about how to convert between these number systems. Like, you are given such number, right? 2, 4, 2, 3, 4 in base 5, and we want to know how to convert this base 5 from base 5 to decimal, right? And from decimal to base 5, like conversions, we should know about that. So I will be doing some tutorials to get huge knowledge about to do the conversions between the number systems, and hope you understood the things, and thanks for watching, and see you in the next video.